Hi and welcome to Steelscape Nano, a series of short courses on designing with pre-painted metal. Simply watch the video, learn the concepts and take the quiz. Start learning today. Topics covered in the next 15 minutes include an overview of the impact of finish depth, exploring the depth characteristics of metal, reviewing metal finish options for adding additional depth, and important considerations when selecting these finishes. Depth refers to a perception of a surface based on visual reasoning and viewing experience. It can be used to achieve greater engagement between a structure and its users. Depth can be used in concert with other stimuli such as tactile sensations from textured surfaces, interaction with light and shadow to further engage building users. Depth can also be used to integrate a structure more effectively into its surrounding environment through altering viewing perception. Part of the sensation of depth arises from our stereo vision, whereby our perception is based on viewing an object with our two eyes and the brain comparing these two images to create a sense of depth. Depth is often created or enhanced through the interaction of a surface with light. Building material integration with natural light is one of the most visible traits of a finish, but often overlooked as part of the material selection process. Natural light interaction influences engagement by altering colours, shadow, and the perspective of design elements. This light is dynamic and constantly evolving based on the time of year and weather conditions, and can create a more organic connection with a surface or structure. The abundancy and intensity of this light also can influence building users directly, including mood and performance. Several attributes contribute to the perceived depth of a surface. These elements include texture, finish translucency or transparency, finish variability and consistency, or the layering of colour, designs and patterns. The use of a light to cast and drop shadows, or the use of light to create reflection, can also create a sense of depth. A number of these attributes are common in naturally occurring materials, as natural materials are created and formed in non-linear fashion, dictated by environmental conditions. This underpins the extensive use of natural materials in some design styles. An example would be the texture and appeal of the wood used in a shake roof. This variance can also work against these naturally occurring materials, as it can make it difficult to assess and control quality, performance, and the longevity of the material. Additionally, the harvesting of naturally occurring finishes may have a significant environmental impact or may contribute to a prohibitive cost point. In the example of the wood shake roof, it is difficult to control its resistance to mould and dirt, how it decays over time, or its ability to resist fire. So why is depth important? Exterior building surfaces, such as roof and wall areas, are typically large flat planes. To meet project needs, these are often skinned in a singular or a limited range of materials to save time and cost or to improve the performance of the total solution, such as weather tightness. Depending on the building style and design vision, improper material selection for large flat planes can detract from the cohesive design of the building. Detractors can include creating a contrast between the structure and its surrounding environment, unnecessarily highlighting building or material imperfections, or creating an unnatural static object in an organic environment. Material depth and dynamic light, in conjunction with other design features such as product shape and colour, can be used to better integrate design features and enhance end-user interaction with the structure. Metal for exterior building surfaces is produced using advanced machinery deploying stringent quality control measures which limit end finish variation. This process produces vibrant colours and a highly consistent smooth surface. The consistency of the finish underpins metal's durability, outstanding longevity, and efficient use of materials. You only need a thin layer of metal and paint. While for many applications this surface aligns with design objectives, for some applications this consistent surface does not integrate with other design features or materials. Modern metal finishes have advanced to provide options for enhanced depth and dynamic light interaction to expand the application of metal exterior in building design. Most metal finishes for roof and wall applications use a two-layer paint system. Depth can be imparted to these systems by either modifying the top layer, adding additional layers, or by using unique standalone paint systems. The following options detail the finish options which can add depth or dynamic light play to metal. Clear coats reflect an additional clear layer over the top of the coloured paint. This can add to the perceived depth of the colour due to the slight difference in depth between the surface of the clear coat and the coloured paint beneath. This method is used extensively to add depth to automotive surfaces. Like automotive paints, clear coats may slightly alter the base colour, and this is most prevalent on whites. There are also tinted and coloured clear coats without primers. Most paint finishes use a top coat over the top of a primer. Primers contribute to the richness of the colour in addition to adding additional corrosion performance resistance. These specially formulated finishes do not have a primer and the finish is somewhat translucent. The translucent nature of the finish enables the texture of the steel underneath to be somewhat apparent, enhancing the sense of depth. These finishes can be tinted in various colours to achieve design integration. These finishes are specially developed to provide finish protection despite the lack of a primer. Micas are specially formulated pigments in the top coat layer to create a sparkling or light-catching effect. Individual pigment particles are flat in nature, allowing for light to reflect at various angles. This creates additional depth and a more dynamic interaction with light. Common micas include silver, bronze, champagne and copper tones. These create a sense of depth through the mica pigment standing out from a base colour underneath. Micas can be both complementary or contrasting depending on the desired look. For example, contrasting mica colours may mix two different mica pigments in the paint, such as a green mica and a copper mica, to get a noticeable contrast. Alternatively, a copper mica provides a consistent copper sparkle to create an authentic metallic effect. Micas can also be used to create colour shifting or pearlescent effects. Pearlescent paints use specially formulated mica pigments that are coated multiple colours to create an evolving colour aesthetic. Pearlescent paints will create a unique colour and shimmer and produce a different colour from different viewing angles. These produce the same visual impact as micas, but in addition to the depth created by the mica pigment, the colour changes from different viewing angles, adding to the dynamic properties of the finish. The paint top coat can be formulated to have a visible, tactile texture. This can be achieved through the chemical properties of the paint that result in crinkling of the surface during the curing process. This crinkling is specially developed so that it does not impact the paint's performance or warrantability. Alternatively, texture can be achieved through adding particulates to the paint itself, which creates surface variability. The rougher texture impacts multiple sensors to add to the depth and the viewer's perception of the surface. This texture can also reduce the glare, light reflection on the surface. The continuous pre-painting production process can be modified in a number of ways to produce more than just solid colours. Printed designs can be achieved by applying an additional 1 or 2 layers of paint over the base coat using a pre-developed design, for example wood grain, brushed steel or granite. The base colour on these designs are a solid colour like a traditional metal finish. The design is achieved by having specialty applicator rolls pre-etched with a design, roll the design pattern onto the metal in a similar way to a printing press. Applicator rolls can be modified to recreate a range of designs. Depth is created through the layering of the different paints. These designs are limited by the size of the applicator roll, which can create a pattern repeat. As a result, these designs typically do not have large distinctive features and are designed in a manner so that the frequency of a pattern repeat cannot be easily identified. While not a finish, embossing is typically performed on site at the location where the material is painted. Embossers work by passing the metal through a set of rollers which press the pattern into the metal. Unlike painting, embossing physically alters the shape of the metal. As these rollers are large and heavy in order to impart the pattern onto the metal, the number of embossing options offered are usually limited. Stucco or wood grain are the most common, and why for many applications, painted finishes offer greater flexibility. The desirability of many of these finishes is the variation they offer over standard colours. Controlling variation in the production process can be difficult. While a consistent finish is produced, these types of finishes are more sensitive to production inputs and as a result have a higher propensity to batch or directional sensitivity. So in summary, depth and dynamic light interaction can enhance the way a building user interacts with a surface. Naturally occurring materials often achieve depth through product traits such as texture and variability. Standard paint systems offer a colourful yet flat finish which may not meet all design parameters. There are a number of finish options available to add depth to metal surfaces, including textured paints, mica paints, print designs and additional pre-coat layers.